Exercise 10. Determine the empirical and molecular formulas for a compound that gives the following analysis in mass percents. Now, this is 100% that's not a pun, a problem that we worked on in Gen Chem. That does not mean that this is not a question that may be a portion of a free response question on the AP exam. So being able to do these basic things, and when I say basic, I mean they're first year things, can get you points on the AP exam, right? There are several different skills that are going to be assessed. This will probably be one of them. And I do mean probably. I mean, in the vast majority of the time, there's at least one of these types. Not at least one of these types of problems on the AP exam. So I'm going to show you two different ways right now. I'm going to show you the classic way that we would have done in Gen Chem. Then I'm going to show you a way that you may use if it works for you. It's more calculator work. Well, I'll talk about it when I get there. So, following mass percents. Whatever this substance is 71.65% chlorine, 24.27% carbon, and 4.0% hydrogen. Now remember, anytime you're given an analysis in percent, assume 100 gram sample. Because what that allows you to do is it allows you to get rid of these percentage signs and replace them with grams. Because 71.65% of 100 grams is 71.65 grams, right? So it's a very, very easy conversion to do. Now, from Gen Chem, we would take each of these values and we would convert them into moles, right? We would convert from grams to moles. And so let's set that up over here. I'm going to have to write a little bit small and compartmentalize to make sure I have enough room to show both strategies that I'm going to use. I have 71.65 grams of chlorine. I have 24.27 grams of carbon. And I have 4.07 grams of hydrogen. Now I'm going to have to convert each of these into a molar amount, right? A molar amount. So I'm going to use the molar mass of carbon, which periodic table 35.45, 35.45 grams for every 1 mole. Carbon, I know that one off the top of my head. 12.01 grams per 1 mole, and hydrogen, that's 1.01 grams per 1 mole. Grams will cancel, moles will be left on each of them. So when I do these calculations, I'm going to have some calculator vomit, I'm pretty sure, so let's see how it goes. Oop, mistyped. Alright, so there's one of them. There's the second one. And there's my third. Alright, now, let's see, I am doing, I guess let's go, we're doing division here, so let's do 3 significant figures there, 4 significant figures there. Alright, we can do this. 2.021, that would look like. Here it would be 2.02. That 8 tells me to round that up to a 1. And then this one's going to be 4. Actually, this one's just 3 significant figures, so I'm going to stick this with 4.03. Alright, so these are all going to be moles of each substance. That's the C for carbon. Now, if you guys remember from Gen Chem, I would take the smallest value out of this list that I just acquired, and I would divide all molar values. In this case, I have 3 by that smallest number. So these are tied for the smallest value, so I'm going to divide everything by that smallest value. Now, just looking at this, you can see that that's going to end up being a 1, a 1, and a 2. And these are going to be the subscripts for the empirical formula. So it's going to be Cl1, C1, H2. Now, the way we normally would write this, we would write the C first, then the H, and then whatever else we have. In this case, it's chlorine. Do not worry. This is the best correct answer. It takes into consideration convention for writing answers, but for formula. But if you were to write this on the AP exam, you would get full credit, right? This is A-OK. It checks out. It shows that you've done everything. It shows that you know that the ratio of chlorine to carbon to hydrogen is 1 to 1 to 2, and you're doing what the question asks. So don't freak out about that. And so there's one more step here. So this is my empirical formula. So empirical formula. The question asked us for empirical formula and molecular formula. We just did empirical formula, so we got one more. Now, I'm going to use this bit of information right here. Okay, so the molar mass of whatever substance this is has a mass of 98.96. So what we want to do is we want to add up the mass of 1 carbon, 2 hydrogens, and 2 chlorines. So let's do that. So 1 chlorine is, let's see, 35.45, I believe. 1 carbon and 2 hydrogens. Ooh, that's 49.8. 49.8. How does that relate to this number that the molar mass gave, that was given by the problem, 98.96, divided by that number I just got? Oh my gosh, that's 2. Oh, it's exactly 2. Holy cow, it's exactly 2. And so what that means is that there are 2 units of whatever this is. There's 2 units of it. So the molecular formula is going to be C2H4Cl2. Boom. And that's your correct answer. Now, I want to show you how to calculate this using the list function in your calculator, because this is a function that we'll use a little bit later on in the course when we get to kinetics, and it'd just be nice for then that you're in the future that you're a little bit familiar with the list function. Now, if it was me on the AP exam, this problem, I would do this 100% because this makes sense to me. Like, I get it. This is intuitive for me. This makes sense. And if this makes sense for you, do it. I'm showing you this next strategy just to get you a little bit of experience with the list function. And hey, if it makes sense to you, keep on doing it. So here we go. So there's a list function, and the way we're going to get to it is to press the stat button. And we press 1 for edit, and we get to all these different lists. So L1, L2, L3, I can press over L4, L5, L6. And so there are a lot of different lists that I can use. You might think, what is a list? Okay, why do I need a list? Well, when we look at these functions that we just carried out, we had this list of masses, right? There are lists of masses, right? Mass, mass, mass. And we were dividing by the molar mass of each of those values. And so this is actually a list 1 and a list 2. And so what we were doing is we were taking the value from the first list and dividing it by the value from the second list, right? And we would get these values right here. And so let me show you how to do that. Now, for a substance that only has 3 different elements in it, it's not that big a deal. But if you're talking about something that has 5 or 6 or 7 elements in it, this might be a little bit more convenient for you because it'll end up being faster. But for something with just 3, maybe not so much. So my list 1 is going to be the mass values that I was given. Right, so that's going to be 71.65, 24.27, and then 4.07. Now my list 2 is going to be this thing that I'm going to be dividing by, right? So this is going to be the molar mass of the individual, sorry, pointing off the camera, the molar mass of the element. So 35.45, and then 12.01, and then 1.01. And as you can see, these are the numbers that I've already used in my calculation. So these aren't a mystery. Now, what I'm wanting to generate in my list 3 is the value from list 1 divided by the value from list 2. And you can see that that's actually what I did here. So my first list 1 value is 71.65, and then I ended up dividing it by my list 2 value, which was this. And you can see that in order to make the units cancel in the way that I want them to cancel, I ended up dividing this term. So I'm going to divide my list 1 term by my list 2 term. And so my list 3 is going to be equal to list 1 divided by list 2. And I'm going to plug that into my calculator exactly like I've shown you. So the values for list 1, 71.65, enter to go down to the next value, 24.277, go down to the next value, 4.07, enter. Now I'm going to use the right arrow to get to my list 2, 35.45, enter, 12.01, enter, 1.01, enter. So when I press the right arrow one more time, I get to list 3, and so I could start entering values for list 3. I don't want to do that right now. I want to press the up arrow to get to define what list 3 is. So now I'm highlighted on list 3, I press enter. That's going to put my cursor down here at the bottom, and I am going to write list 1 divided by list 2, just like I have right here. So the way you do that, notice down here with the 1 and 2 buttons, the second option, blue, right, is list 1 and list 2. So I'm going to go second, 1, that's list 1, divided by second, 2, which is L2. I'm going to press enter. And notice L3 has given me the exact same values that I generated on my first go round. Now you can look at list 3, you can say, oh wow, this is the smallest value. I'm going to divide all of these by the smallest value. It's pretty easy to see that this divided by this is 1. Obviously this divided by itself is 1. This divided by that is 2. So you get your 1, 1, 2. And so you can kind of see that as you go forward. Now again, this is just a substance that has 3 different species in it. 3 different elements, so you're not going to save a lot of time using the list method. So pick which one makes more sense to you. If you really like using the calculator, use the calculator. Use the list method. If you want to depend on simply showing your work and setting up your conversion factors, do it. Both of them will generate the correct answer.